Okay. Okay, so today I'm going to start this part. Okay, and I have already covered the Scala concepts. So fundamentals of the Scala basically, and functional programming concept is there, like lambda operators and OOPS concept in the Scala, like how to create a class, creating a constructor, primary constructor, secondary constructor, and we can write like some collections. Like we have used the collections, file handling, exception handling. So these all are the things that are part of the Scala. Now we are going to start this part. So here there are multiple flavors are there using the Spark. So one is Python, another one is Java, and another one is Scala. So we are using here Spark with Scala. So whatever APIs of the Spark we will be using, that API will be in the Scala. Okay. So we can write the same program either in Python or Java. So it is up to the choice. But that particular language we should know. When we are going to start in any other language, then we should have the knowledge of that particular language, especially about the syntax. Okay. But conceptually, every language is having the same fundamental concepts. There the classes are there, concepts, constructors are there, inheritance is there. Okay. So these mostly concepts are the same in most of the programming language, but some of the concepts which are specific to that particular language, is having traits, like instead of like we can use abstract classes, but traits is another way, like provide a multiple inheritance in Scala. And function is basically when we can pass function as a parameter, we can use higher order function. And anonymous function is the lambda operator we can use to define the anonymous function when we can define the function at the runtime without giving a name of the function. Okay. So now we see like what we have to achieve in the Spark basically. So Spark is computation framework basically. Okay. So okay, I just first compare with the Spark with Hadoop. Okay. So first two sessions I will be doing theoretically. So understand the concept of the Spark framework, right? What is the Spark and how we can use the Spark, and how the Spark is better than the MapReduce. And if we compare the Spark and MapReduce, so what are the challenges are there in the MapReduce? Those are overcome in the Spark basically. Okay. So first of all, if we compare with Spark with MapReduce, okay. So Spark is especially for the batch processing as well as real-time processing. Okay. So batch processing, like when we have the historical data. So when we call it batch processing means when we have the data, as a historical data. Okay. That is the one thing we can do with Spark, but Spark is not meant for that. Okay. We have already MapReduce for batch processing data. Okay. But Spark real use is real-time streaming data. Okay. Or near real-time. Okay. So if I say like data is coming on the fly, that data I'm going to process. So then I will be using the Spark. Okay. And the main advantage of the Spark is it is having in-memory computation. What is in-memory computation? In-memory computation means whenever it is processing the data, it process data in memory, and store intermediate output data, in memory itself. But in case of MapReduce, it stores the data, it stores intermediate output data on the disk. So that is the reason the MapReduce job is slower than the MapReduce job is slower than Spark job. Okay, so we say Spark job is 100 times faster in memory and 10 times faster in hard disk. So when we are having a Spark, so our configuration should be very high. That is our first prerequisite for Spark. So if I talk about the Spark, I need a very good configuration as in terms of memory. Okay, then I can process the data using the Spark. Okay, and another advantage in the Spark is having iterative model. Spark has iterative model to test the data. Okay, so what is the difference between the iterative model and the batch model? Like batch model is like I am getting the data in a bulk and I am processing the data. Okay, but Spark is having the iterative model, so data is coming in the chunk. Data is coming in small chunk, and the data is coming continuously. The data is coming continuously. Data is coming continuously. If I'm talking about the data, like it's a streaming data. If I'm talking about the batch processing data, that data will be coming as same, like as a MapReduce gets the data. Okay. So these are the benefits are there. Like Spark is having the iterative model, Spark is having in-memory computation, and Spark is having the DAG. Spark job maintains a DAG. So what is a DAG? DAG means direct acyclic graph. Direct acyclic graph. So it is basically a graph. It is a graph to maintain states or actions, whatever action it is doing, actions in a graph form. Okay. So what is the advantage of this? So here the lazy evolution concept comes in the picture. Like suppose I have a four transformations are there, 4 transformations and 1 action. Okay. So when I'm executing a Spark job, so when I call action, action is like collect. Okay, collect is the action. So this collect action will invoke all 4 transformations. I will tell about what are the transformations are there in Spark. So it's like a map is there 1 transformation, flat map is a 1 transformation, filter is a 1 transformation. So I'm calling these transformations when I'm invoking the action. So this is the lazy evaluation there, and these all transformation are the part of the DAG. So what is the advantage of the? Suppose one transformation got failed. Suppose I say flat map got failed. Okay, so it will recompute flat map got failed. Okay, then it will recompute again from flat map. Okay, so the benefit is there. If my job is failed, if my job got failed in Spark, so it will recompute from the failed mode, from failed action. Okay, failed transformation, not from the scratch. So this is the benefit. This is the benefit as compared to MapReduce. Okay, so they have given the concept of RDD. I will tell what is the RDD, resilient distributed data set. So this is all the fundamental concept in the Spark. Because of the Spark is now more powerful and it is having a more benefit as compared to MapReduce. And one more thing is, MapReduce is completely written in Java. MapReduce written in Java. Okay, so here when person is writing a MapReduce code, Java knowledge is required. Right? But Spark is using library functions. So whatever code I am writing for Java, like for different transformations like map, flat map. So I need to complete Java code I need to write. But here in Spark, I'm using a library function like map, flat map, join. So I have a library functions and I can write less code. I can write less code for more productivity. So that is one more advantage using the Spark. So even I'm using a Spark Java, but I don't need to write the MapReduce lengthy program in Java. Okay, so that is the benefit. Is it clear this thing? What is the difference in the Spark and the MapReduce, and what are the basic features of the Spark? Right? Okay. So now there are some scenarios are there where the mostly the Spark is being used. Okay, this is when the data is really very large, and I want to process the data. Not only process the data in a faster way, I need to I can use in a very I can use the different modules in a one single place. That is in the Spark is there. Suppose I want to apply the machine learning things. So Spark has provided Spark MLlib. Okay. If I want to use the SQL, same like Hive. So Spark has provided Spark SQL. If I want to apply graph Spark graph module. So graph is basically I can create graph kind of functionality I can provide. So graph is mostly used for relationship between the different users. I can define the relationship like edge and vectors. Graph mostly used for defining edges and one more thing is vertex. Okay, so this is used right in Facebook. This concept is used in the Facebook for defining friends of friends, like friends of friends. Like I want to get the relationship like this. Like I want to get likes of the friends of friends. So then I need the graph kind of functionality. Okay, and Spark streaming is there. So streaming is basically when I have a streaming data like data is coming from some real-time data. So that kind of streaming data, there is a module is there, Spark streaming. Okay, and on top of all these are the base is there, Spark Core. So Spark Core is a fundamental module which is base of all these modules. Spark MLlib, Spark SQL, Spark Graph, Spark Streaming. So Spark Core is a base. Okay, and there is a transformations and actions. Okay, so core API is there in the Spark Core. Okay, and Spark Core is common to all the libraries. Whether I use MLlib, SQL, Graph, everywhere I will be using the Spark Core. Like transformation actions, I will definitely use. Okay. So these are the use cases. I will share this PPT, so you can just explore more. Like what are the e-based use cases are there? How they can use how they are using the Apache Spark in the EA. Okay. So these are the different use cases. One use case is for the streaming one. One is a Spark SQL, like a SQL kind of functionality I want to do. I have a data in Hive table. I want to read the data using Spark, so I can use the Spark SQL. Even Spark SQL, I can read the data from the different data sources, like Mongo, Cassandra. I can read the databases in Oracle, MySQL. So different RDMS database, I can read the data. Even file system data also I can read. So here Spark is providing ingestion of the data and analytics of the data. So if you have seen, like we have in Hadoop, there is scoop is for ingestion. Scoop is used for ingestion. After ingesting the data, we use Hive. Hive is used for analytics. Okay, or we can say MapReduce is there for analytics. MapReduce is used for analytics, or we have tools for the analytics. Okay, so these are the different tools are there for analytics in Hadoop. But if I talk about this Spark, so Spark is doing ingestion and analytics both. Okay, so whenever you are going to do analytics in Spark, Spark is going to do analytics. So it needs to ingest the data first. Analytics but before that, it has to ingest data. Ingest data from different sources. Ingest data from different sources. Okay, so these sources, n number of sources are there. SQL sources, NoSQL sources, some sources like file system, CSV, XML, JSON, any file system sources, or the sources maybe we can say Snowflake is there, that is a SQL data warehouse tool. Snowflake is there. Something like Elasticsearch is there. So these are the sources also. Okay. So through Spark we can do ingest the data as well as analytics of the data. But in Hadoop, we have to ingest the data using the Snoop, and then analytics we have to use either Hive or Pig or MapReduce. But still these tools are not providing as a programmatic way except the MapReduce. So MapReduce we can write a code, there we can write our custom code to the manipulation. Okay. So here Spark is providing a programming approach to write a code to apply the transformation. So we can write code to apply transformation and action. Okay, so this is a code library part, Spark code library. Okay, so I will tell about what is a Spark code library. So they are the different. These are the use cases like where we can use the Spark. Okay, and this is a Spark ecosystem. Like we have a Hadoop ecosystem. So in Hadoop ecosystem, some of the tools are Hadoop is there, but Spark tool also we can use. So Spark SQL is there, Spark MLlib is there, Spark streaming is there, and Spark core is there, and we have the Spark graph also there. So these are the different modules. Graph is not given. Yeah, graph is given. So Spark core, Spark MLlib, Spark graph, Spark SQL, and Spark streaming. Okay. So whenever I want to do some machine learning part or graph, I have these modules. If I want to do SQL, I have this module of Spark. If I want to do streaming, I have this part of the Spark. And if I want to do batch, simple, I want to do the batch, like historical data, I want to analytics, then I will use Spark core. Okay, so these are the different modules we can use. And if I compare with the Hadoop, so Hadoop, there is a Mahout is there for machine learning. In Hadoop, Hive and Impala is there. If I talk about some other streaming libraries, so Storm is there. Okay, and NoSQL, if I talk about, there is HBase is there. Okay, so these are the other different tools ecosystem. Okay, but the replacement of these Hadoop tools, we can use Spark component. Okay, so there are these 5 components we can use, and one more is there, Spark R. So Spark R is basically integration of R language with Spark. Okay. So I have already discussed like what are the advantages of the Spark is there, in-memory performance is there, and we have ease of the development, like we have a productivity is very high because we are using the libraries. So because of the libraries, we are writing very, very less code as compared to like we are writing in the MapReduce and the Hive and Pig. Okay. So these are the benefit of using the, and combination of Hadoop and Spark is, actually Spark is only the processing part. Spark is the processing engine only. But it needs some storage part. So Hadoop SDFS it used as a storage. Okay, so that is the combination with Hadoop and Spark is the Hadoop storage part, SDFS, it will be using as a storage, and Spark is as a processing engine. Okay, so that is a combination. Is clear so far? These are the theoretical concept. So I am just explaining the theoretical concept, but later we will be coming to the practical part. It's fine so far?
Yes.
Okay. So I already discussed about are the major 5 modules. Spark core is a base, like this is a base module, and top of that we have other different modules are there. Spark SQL, Spark Streaming, Machine Learning, Graph, and Staka. So mostly, if we talk about the big data engineer role, so not dealing with machine learning and Spark R. Okay, so mostly we are dealing with Spark core. Obviously, this is a base. And then we are dealing with Spark SQL because we have to integrate with Hive, because we have to read the data from the Hive or some other SQL data sources, and we have to write the data into some other data sources. So we are using Spark SQL. And Spark Streaming we are using for streaming data, where the data is coming from streaming sources like video streaming, audio streaming, or some text streaming. There we are using the Spark Streaming module. And basically, we use the Kafka. Like Kafka is a tool which can read the data from streaming sources, like Twitter, if I talk about. So Twitter handle, like people are posting the tweets, and we are on the fly reading the Twitter tags handle, and Kafka is reading the data from Twitter, and then we are getting the data in Spark. Okay, and then we are doing the processing on the data. So one example of the Twitter I will show, where we will be reading the data from the Twitter through Kafka, and then Kafka we are reading the data in Spark Scala consumer. Okay. So before that, I will be doing some conceptual knowledge, like how to use the Kafka. Basically, when we are going to start the Spark streaming, I will tell about the Kafka, so that it will be easy to understand how to integrate Spark with Kafka, Spark streaming with Kafka. But before that, we can cover Spark core module and Spark SQL module. Okay, because there is no need of Kafka. Okay. So this is the one by one that they are explaining about the modules. So basically, Spark SQL is mostly used for the SQL part. It's a structured data. Okay, when we are talking about how to process the structured data, so we use the Spark SQL. Okay, so Spark SQL, similar like a Hive, we write a Hive SQL, Hive query language. Same way we use Spark SQL, and same query language we can write. So either we can use a data frame, or we can write the SQL query using the Spark SQL. Okay, and streaming is basically some data streams. Basically, when we are getting the data through streams, so we use this module. Okay, machine learning is for the machine learning, and GraphX is basically for parallel operation of some graph library we want to use to manipulating the graph. So we use the GraphX. Okay. And the Spark R is used for like I want to integrate with R language with Spark, so I can read the data in R Studio from Spark through Spark. So if I use only R, that can do also analytics, but you will not get the benefit of Spark. So what is the benefit of using the R on Spark? So Spark benefit is in-memory computation. So if you are using R on Spark means, so whatever analytics you are doing in R language, you are giving the support of Spark. You are using the Spark session, and then you are executing the job using the Spark cluster. So that R, whatever analytics you are doing in the R, that will be more faster than the without using the Spark. That is the benefit of using the Spark, R on Spark. Okay. So we can do that also, right? We can integrate with Spark with R, and then we can do the analytics in R language. So language will be the R only, similar like Scala, Python, Java. So we will be writing the code in R language. Okay. So Spark core engine. So Spark programs when we are writing, so where it will be executing, that question comes, right? So we need, like generally we know, right, when we are writing a web application, so we are writing on server, right? We are using some Tomcat or some JBoss or some WebLogic, some application server we are using. So the execution engine, where will be execution engine? So either we can use Yarn. Yarn is a part of the Hadoop 2 framework, Hadoop 2.x framework, right? So Yarn is yet another resource negotiator. So that Yarn we can use for Hadoop job, Hadoop Spark job. So we can use Hadoop as a storage part here, and Spark is a processing engine. So we can use Yarn as a processing part. We can use a Yarn. Another server is Mesos. So Mesos is another one. There we can use as a cluster manager of Spark as a Mesos, or Spark standalone. Spark standalone means simple. I don't need any server things. I don't need to store in HDFS. I have to simply run a Spark program and I have to get my output. I don't need to store my HDFS. So I can go for Spark standalone. Okay. So either one of these we have to choose. If my data is present, if suppose my input data and output data I have to store in HDFS, I will go with that. If I have to do some clustering things, suppose I have to make a cluster, like you know about some Docker and Kubernetes cluster, that is a replacement of the Mesos. So if I need a cluster kind of part, then I will go for this kind of execution engine. Otherwise, I can go for Spark standalone. That is very simple. Just simple, like just I have to execute the program and I have to get my output in the file system, in my local. Okay. So in the cluster we talk about, if I want to execute an Hadoop cluster, I will go for Yarn. If I have to create a separate cluster, I can go for Mesos. And if I want to run in my local, I can use a Spark standalone. Okay. So I can create a jar and I can submit in my local cluster I can create. Okay, I don't need to use Hadoop environment. Okay. So basically here, if I talk about the programming part, so programming languages are 4: Scala, Python, R, and Java. Okay. So R is especially for the Spark R. Other Scala, Python, Java, we can use any one of the modules. Like Spark SQL, we can write in Spark Scala, or PySpark, or Spark with Java. Okay. And what are the execution engines part? These are the Yarn, Mesos, and Spark standalone. And what are the storage part? So HDFS will be coming here. Yarn will be for HDFS, and local will be Spark standalone. Okay. So we can use Spark standalone for the local, right? We can use local. So this is a high-level Spark architecture. So we know in the MapReduce we write 3 classes. Okay, we already know. Right, we write 3 classes. One class is a driver class. If I write a MapReduce program, so I write one driver class, okay, one mapper class, and one reducer class. Okay. So these 3 classes I need to write in MapReduce. Okay. If I'm writing a Spark program, I need to write only driver class. Okay. Driver class I will write, and I will call some other classes for the driver, but only I need driver, and driver is having a main program. Whether I am writing Scala, Java, or Python, I need to write a main program. So when I create some Java project or Scala project or Python project, Scala or Python, suppose I write one code in Java, Scala, Python, I create one Java, one driver class. Okay, and this driver class I create, and then I create a jar, and then I submit a jar on cluster. So there is a command, Spark submit. Like Hadoop jar, there is a Hadoop jar command is there. Like when we are writing the MapReduce, so we have Hadoop space jar, then we give the jar name, then we have main class name, then input folder, input file, and then output folder path. So like this we go. When we are writing a Spark, so we have to create a jar, and when we are submitting a jar, so there is a command Spark submit. Then minus class we need to tell. So this will be our main class name. So suppose my main class name is my class. And then I can specify some other parameters like executor, score, driver memory. So there are so many parameters we can provide it based on our requirement. Okay, course. So basically, what is the architecture here? So this driver program, when I do this Spark submit, so when I do Spark submit here in the driver program, So it is creating a one Spark context, and this Spark context is invoking the cluster manager. So there are the three cluster manager are there. I already showed on the one is Yarn, another one is resource Yarn, and standalone and the Mesos. So if I'm using a Hadoop environment, which can call here Yarn cluster manager. So basically, I don't need to call this. Driver program itself will invoke that cluster manager. Once the cluster manager is invoked, so our worker nodes are there. Each worker node having the executor. Executor is executing the task. Like in the Hadoop, right, there is a job tracker or resource manager is there, right? So each node, there is a node manager is there in MapReduce. Okay. So if I tell the concept there is a name node is there and data nodes are there in Hadoop HDFS part. If I talk about the processing part, so we have the resource manager and node manager. So this resource manager we are calling here worker node in its part. Okay. So ultimately each worker node is having the executor. Executors are having a task, and here is a cache is a memory. So whenever executor is executing the task, it will store the result in the cache. When they are executing the next task, so they will be reading the input data for this task from the cache. That is the reason it is not storing the data in disk. That is the reason the Spark job is faster. So all the executors, all the worker nodes having the executors, and these executors will be performing their own task. And once the tasks are completed, the result will be returned to the cluster manager, and cluster manager will return the result to the driver, and driver will give the result to the client who is invoking the program. Then I will see the output. Then I will see the output on my screen. So this is the process, right? This is the process, and here is the cluster manager is a centralized component which is interacting with driver program and worker nodes. Okay. So whenever anybody asks about the Spark architecture, so high level architecture, this is high level architecture, how the component interact with each other. So here the driver program is initiating the Spark context, and the Spark context is initiating the cluster manager, which cluster manager will come into the play, and that cluster manager will be distributing the task to the worker nodes. So how these tasks are coming here? These tasks are provided by the cluster manager, and it will be executors on that worker node that will be executing their task. And once the tasks are completed, the result will be accumulated and given back to the cluster manager, and cluster manager will give to the driver, and driver finally return to the end user. Okay, so this is a flow. How this flow works. So this is explained here. This is explained here. Okay. So how many deployment mode is there? This is altogether they are talking about the cluster manager only. So Spark can be deployed on the Yarn when we are using the Hadoop. Mesos is for the private cluster when we want to create as a deploy we want to do. And standalone means local cluster, like launch a standalone cluster quickly without a third-party cluster manager, simply just in the local machine. Or another way is EC2 also. So EC2 is nothing but some type of machine will be there, right? Whether it will be the machine will be the Linux, Ubuntu, Linux AMI, so any and the CentOS. So different kind of machines will be there, and we need to install the Spark on EC2. Then we have to we have to use now we have to deploy the Spark job there. So we need to write a one script. That script will launch a cluster on EC2, and there we can deploy our job. Okay, so that is the way to deploy on the EC2. Okay. So there are the two modes are there. One is a client mode and one is a cluster mode. So in Yarn, there are the two modes. So client mode, so what are the parameters I need to change in the Spark submit? So in Spark submit, I am giving ---- class. After that, I am giving master Yarn, and deployment mode is a parameter. If I give this parameter client, or if I give this parameter as a cluster, so it will change the mode. Okay, so when I give the client mode means where is my running a driver program. So this driver program is running. So basically in cluster mode, the yarn application master comes in picture. Okay, so my driver program is not running locally, it will be running in the yarn. Okay, but when I talk about, when I say client mode, my driver program will be running locally. Okay, it is interacting with yarn only. Both are yarn. Difference is in client mode, driver program is running on the same machine where you invoked it. Okay, but in cluster mode, your driver program will be distributed. Your driver program will be distributed to the different workers like this. Like your driver programs will be shipped also in the different like basically this yarn it will be running. Rather than running here, it will be running in the cluster manager. Okay. So sometimes we are using cluster mode or sometimes we are using the local mode. So cluster mode generally we use when we are using the in the cluster environment, we use a cluster mode, this one driver manager cluster. But if I want to get a result directly from here, okay, I don't need to, like if I'm using the just I'm getting the data from the different workers and return back to the driver. So driver will be running itself here. But when I want to execute my driver program in the yarn, then I will be using the cluster type mode. Okay, so then I will use master yarn and deployment mode is cluster. So when application runs on yarn resource manager, okay, so basically the cluster mode will be when we are running driver program in the yarn remotely, and when the driver program running locally, that is the client mode. Okay, you can understand here in the cluster mode, the Spark driver runs the application master on the cluster host. A single process in a yarn container is responsible for driving the application request resources from the yarn. Okay, so our driver program is coming here in the Spark application master here in the cluster manager. Okay, it is not running in the client side. Okay, and then the driver is there in the client side. If you see in this diagram, this is the client mode. So in client mode, driver runs on the host where the job is committed. Okay, the application master is merely present to request executor container from the yarn, and client communicates with the container to schedule work after they start. So here, to driver program, we don't have the control. But if in the client mode, we have the control. But when we say in cluster mode, we don't have the control on the driver program because driver program is running in the yarn container. Okay. So you can say both are specifically used at their end. Sometimes you use the deployment mode client and sometimes you use the deployment mode cluster. Okay. So suppose if I want to generate some output file in my local, so I want my driver program running in the client mode. But if I want to generate my output file in my Hadoop cluster itself, okay, so I have to define my client mode, deployment mode cluster, so that my output file will be generated on Hadoop only. Okay, because finally the control will come back to the client application in case the driver we are invoking from here. If we are invoking driver from yarn container, so my output file will be generated over here only. Okay, so it's basically the requirement, like where I need my output data. If I need output data to be stored in the Hadoop environment, I will be running in the deployment mode with the cluster. Okay, is it fine? Is that understood?
Yeah.
Okay. So basically we can start this Spark like now 2 ways we can test our program. One is interactive shell is there. Just simply we write a Spark to -shell on the command line. So one Spark shell will come. So this Spark shell is nothing but Scala shell. But here we can write Spark code as well as Scala code. Okay. But when I write only Scala, So that time also Scala shell will come, but that Scala shell will not be used for Spark. Okay, so that is the difference. So this Spark shell is used for as an interactive shell. So when I want to write some code here, I will get the result immediately. Another way of writing a Spark program, like I can write in IntelliJ. So I was already writing some Scala code, right? This Scala code is there. So this Scala code I'm writing here, instead of this, I can create a one Spark project, and I can write a Spark project code here, and then I create a jar, and then I can submit on the cluster. Okay, so that is another way of writing the program. But in this way, when I'm using IntelliJ, so I have to write a program in IntelliJ, create a jar, and submit on the cluster. So it is lengthy process. But I want to test my code, I can simply write code here and I can see the result. So for testing purpose, if I want to do development fast, I can test it here only and I can check it out my output and I can verify the output. Okay. So if I want to start this Spark shell for the yarn, so I have to give one parameter here, minus master equal to yarn. If I don't give it, it will be as a standalone mode, it will be running, local mode it will run. Okay, suppose I want to read my file from SDFS. So I have to give minus master equal to yarn. If I don't give it, it will not read the file from the Hadoop yarn. Okay, it will read the file from the local file system. Okay. So this is the way I can create a one hello world program like a Spark application. I have a SRC code is there, build SVT is there, or I can use the Maven like pom.xml. And then I can create a jar of this project and then I can submit in the cluster. Okay. So this is a build.svt format, like how we have the pom.xml. Similar way we can write build.svt. Okay. So SVT is the one tool we can use for building the application. Another tool we can use the Spark. So here I am using build.svt. You can see here, this is a build.svt. But here I am not using still some jars because it is using this all programs are using Scala only. But when I need Spark, I need to add the dependencies of the Spark here. Okay. So I need to add the dependencies of the Spark here. Okay. If I am using a Maven project, if I am using some Maven project like this pom.xml, so here right now no dependency of the Spark is there because this code is simple plain Scala code. But when I am writing a Spark code here, I need to add the dependencies here as a dependency tag. So all the Scala dependencies I have to add. One dependency for the core module, one for SQL, and one for streaming. So suppose my code is related to core only, so I will add the core. If my code is related to SQL, I have to add core and SQL both. If my code is related to streaming, I will use core and streaming APIs, streaming libraries. Okay. So I will show both the ways. This is a Spark submit command. So once I create a jar, I'm just writing a one command Spark to submit minus class name and minus master yarn I'm giving. And then I'm providing the jar path where my jar is located. So once I give this command, my job will start executing and then I will get the output. In the console, I can see the output. Okay. Or Spark Wave UI is there. So this is a localhost 84040. This is a port for the Wave UI. And we can see the Spark job is running like this. So here we can see the stages stored. So like we can analysis of the job we can do here. What is the performance of the job? What is the executor performance is there? We can everything we can analyze over here how job is executing. And this is a Spark 2.1 version they are using. The latest version is 3.0 and 2.4 or like 3.0 version is the latest version. 3.0 is the latest. Okay. So I will tell the difference between the Spark 1.x and 2.x. So before 2.1.0, 0.6 version was there. So that is Spark 1.6 and 2.1. There were some couple of differences. So Spark 2.x is using the Spark session, but Spark 1.x is using the Spark context. So Spark session is a wrapper on top of the Spark context. Okay. So what I will do next, this is okay. So next I will tell some concepts are still remaining. Some concept related to RDD concept is there. Tomorrow I will cover the RDD. Next module is playing with Spark RDD. So I will cover some more theoretical concepts. So the basic fundamental unit in Spark is RDD, resilient distributed data set. And why it is called RDD is a resilient, what is a distributed, and what is fault tolerance is there. So basically, what is RDD and what is the purpose of RDD and how RDD is basic fundamental unit in the Spark. How on top of the RDD, then there is a data frame is there and data set is there. Total 3 APIs are there. One is RDD, the basic fundamental unit. Then top of the RDD is data frame and one is the data set. Okay. So I will tell about these features of the RDD, how to create RDD, and then what are the transformations are there in the RDD. These are the transformation list. Okay. So these are the transformation list: map, flat map, group by key. So these are the all programmatic part, like how to apply map, how to provide the parallelized function. So these all are filter is there. Collect is there. Collect is the action. Okay. And group by key. This is also transformation. Collect is the action. So this way we have to write a code. Like this code if I write, and then I can paste it on the Spark shell. Okay. Then I can get the result. So these are small code snips. We can understand how to apply map, how to apply filter, then how to apply group by key, how to apply join, how to get the result finally. Okay, so like this, small code snips are there. So I will show the demonstration of these all examples. I'll share this PPT. 2 PPTs I will share to you. One is the first one is that this one. This one is the introduction of the Spark is here in this one, and this one is RDD concept and data frame concept is there. Okay. So any more question? Any question? So I will do the setup on the Cloudera Quick Start VM, or we have already Ubuntu VM. There also Spark is running. Okay. So anywhere we can do it. So I'll show the Quick Start VM. So there we will do practice of the examples. Okay. Yeah. Thank you. Thanks all.
Thank you, Arvind.
Yeah. Bye.